Hey everyone, in this chapter we're going to be talking about risk, return, and portfolio theory, which will feel like a stats class, but in the context of finance. What we're going to see in this chapter is basically how to calculate return, what return even is. We'll see the most common measure of risk, which is the standard deviation and all the things that come along with that, so covariance, correlation, and so on. We'll also then see how to calculate those same things, but for portfolios. It will be kind of a combination of what we're seeing in this chapter. So let's get into it. So what is a return? A return is simply the money you get back for an investment, right? If I give you $100 and a year from now you give me back 110, then my return was $10. Now there are a couple of things you need to know about calculating returns. And the first is that a return on investment actually has two components. There's something called the income yield and something called the capital gain yield. The income yield is what you make from the income generated by the asset. Easy example would be rent. When you buy a building, you can rent it out. And for as long as you own the building, you can generate this revenue just by owning the building. Well, you pretty much have that in any financial asset as well. Bonds pay you coupons, stocks pay you dividends, same concept. So the income yield is the return expressed as a percentage or expressed as a percentage of your initial investment, but strictly from the income component or the revenue component of your investment. So that's where we'll start. Here it says a share of Smith Corporation was selling for $32.16 1 year ago. The stock paid an annual dividend of $3.45. So this $3.45, that's your income. This is your initial investment. That's what we call P0. See, in this formula, P0 is always the old price or the initial price. And then the income is what we call the cash flow for this formula. So the income yield on this, in this case, would be $3.45 divided by $32.16. So you get 0.1073, or if you multiply that by 100, you get 10.73%. So that is your income yield. It's not your total return on investment, because again, this is only part of it, but that's how you find it. Which takes us now to the second part. Oh, actually, we'll do another example, this time for a bond. It's pretty much the same thing. So Marie purchased a bond for $985 1 year ago. The bond paid a coupon of $252. What is the income yield if the bond's current market value is $989? Now you want to be careful with this $989 because we don't actually need it. The coupon or the income yield really just looks at the income received, so in this case the coupon, and the initial investment. So if we did the sum of the cash flows over P0, this is 252 over 985. So that is about 0. I've already converted it to a percentage, 2.558%. Really small return. Okay. Now I said return had two components. The first one was the income yield. The second is called the capital gain yield. The capital gain yield is basically just a percentage change in the price or the value of the asset. So you remember my building example, you can rent it out, that's income. But the building itself will gain value. So if you bought it today for $1 million and you sell it next year for 1.2, or even if you don't sell it, if it's worth 1.2, you have a return there. The increase in the price of the building is a return for you. We call that a capital gain. Now, capital gains don't have to be positive. You can also have capital losses. So for example, if your building loses value, if you buy a stock and the stock loses value, we call that a capital loss. But we go about them pretty much the same way. You see the formula is simple. P1 minus P0 over P0. It's basically new minus old over old, but using the price of the asset. So let me show you how that works. So a share of Smith Corporation was selling for $32.16 a year ago. The stock paid an annual dividend of $3.45. What is the capital gain yield if the stock is currently priced at $34.02? In this case, we do not need the dividend. We just care about the price. P1 is the newer price. P0 is the older price. So 34.02 minus 32.16 over 32.16. Again, you can multiply this by 100 if you want to express it as a percentage. I get 5.78%. That's my capital gain yield. That's the percentage by which my asset increased in value. Now, if you put the two together, here you have your income yield, and here you have your capital gain yield, you get your total return. Now, total return has a few names. Total return, return on investment, holding period return, it's all the same thing. But it's basically just a combination of those two things. So we'll use this example here. Estimate the income yield, capital gain yield, and total return for the following. So you have a $1,000 par value 4% bond that was purchased a year ago for $9.90. So that's the original price. Today it's selling for $9.95. That's your new price. Now bonds. We learned about bonds in the previous chapters. So what is the payment on this bond? Well, the payment on this bond would be the face value times the coupon rate. So we bought a bond for $1,000. It's got a 4% coupon rate, which means this bond pays $40 coupons. You bought it 1 year ago, so you would have only collected one coupon. So then if you wanted to calculate your income yield, it would be $40, that's the cash flow, divided by the original price of $9.90. So that's the first part of this question. That's about 4.04%. Now for the capital gain yield, we look at just the change in price. So P1 minus P0 over P0. So that would be 995 minus 990 over 990. So this would be a really small number, I think. 0.5%. 0.505%. That's your capital gain yield. Just a tiny change in price. The total return would be the sum of those two. So if you took the income yield plus the capital gain yield, the math on this would be 4.545% about. That would be your total return on investment. Okay. Let's do the same thing for this one. Now here you want to pay attention to the fact that the dividends are quarterly, and therefore every year you would collect 4 dividends. So if you wanted to calculate the income yield, and you have sum of cash flows over P0, in this case the sum of the cash flow would be 25 cents 4 times because you had 4 quarterly dividends that you collected. So 4 of those, and you had originally purchased it for $20. That's a 5% income yield. For the capital gain yield, we actually lost money. You see, we went from $20 to $19.50. So you'll see here a capital loss. Still the same formula, P1 minus P0 over P0. P1 is 1950. P0 is 20 over 20. So this is negative 2.5%. So you had a capital gain yield of negative 2.5%. In other words, you had a capital loss of 2.5%. So when you put the two together, 5 minus 2.5, your total return on investment was 2.5%. Okay, so that's how you find returns. Pretty straightforward. We call these ex post returns. I have that written here. Ex post just means that these are returns on investments that have already happened. These returns have already taken place. There's nothing uncertain about them. They're from the past. Later on, we'll see ex-ante, where we're trying to estimate future returns, but we're not there yet. Now, when you have multiple returns, you often want to calculate an average. So you just have to know that there are 2 averages when it comes to measuring averages for average returns. You have the arithmetic average or the arithmetic mean. Everybody knows this. That's your traditional average, where you add them all up and divide by however many you have. The geometric mean, on the other hand, is like, it's an average still, but where you're taking into account the compounding effects of returns, right? Because in the context of returns, your returns are compounding. The arithmetic average doesn't really factor that in. It just adds them up and divides. Whereas the geometric mean, because we multiply, so you'll see the formula right here, you multiply the returns, you are actually taking into account the compounding, and therefore it gives you a better measure of what your actual annual or whatever periodic, whatever period it is, whatever the average return truly is. So I want to go over this. So you've been given these 5 returns, and you're asked to find the geometric mean and the arithmetic mean. So for the arithmetic, it's pretty straightforward. We're going to just add them all up. And then divide by 5 because we have 5 returns. Now, when you're doing the arithmetic mean, it actually doesn't matter if you convert it to a decimal or not. Just stay consistent. So I'm not. I'll leave everything like that. 5.4 plus 6.2 plus 4.5 minus 7.8 plus 10.1. And divided by 5, I get 3.68. That's my arithmetic average. Now, after we calculate the geometric, you'll see that the geometric mean will always be lower. It's always smaller. Why? Because the arithmetic mean, not considering compounding, will always overestimate your returns. So how do we use this formula? It's pretty simple. You have to convert everything to decimals. That's one important thing. So instead of 5.4, it's 0.054. So 1 plus your first return of 0.054 times 1 plus 0.062. We're doing this for all of them. 1 plus 0.045. 1 minus, because it's negative, 0.078. And then 1 plus 0.101. Close it, and then to the power 1 over 5. 5 because you have 5 returns that you're averaging, minus 1. This gives an average return of 0.03495, which is 3.495%. So you see it's lower, but this is the true average. This is really what you made on an annual basis once you consider the fact that those returns were compounding on each other. Okay, so arithmetic mean, geometric mean, again, nothing too complicated, but something to know. Now, we've seen historical returns, which we call ex post. Now let's take a look at future returns, which we call ex ante. So instead of calling it an average return, we're going to call it an expected return, mainly because it has not happened yet. But they mean essentially the same thing. Average looks back, expected looks forward. But here's the formula for the expected return of a single asset, or so like a stock, for example. It's the sum of the return times the probability. It's the same way that you would calculate expected value in any context. You have a probability and you have an outcome. And for each outcome, you want to multiply it by its probability to basically get the average. So here, for example, you've been given 3 situations. The economy can either go into a high growth state, a recession, it's actually 2. So the economy could either go into a high growth or into a recession. You have the respective probabilities and you have the outcome for each one. So what we're saying here is, if the economy goes into a high growth state, stock A will earn 50%. If it goes into a recession, stock A will lose 10%. So what is your expected return? What is the average return per year? Well, if you follow the formula, all you're going to do is the return multiplied by the probability, and you're going to do that for each of them. So the expected return for A would be 0.5, that's the 50% return, times 0.7 plus negative 0.1, that's the return, times 0.3. So this gives you 0.32 or 32%. So the average return is 32%. The expected annual return is 32% for stock A. Okay. Now, what about risk? So the standard deviation is how we measure risk. There are many different ways to measure risk, but total risk, what we're seeing in this chapter, is measured by standard deviation. In stats, you would have learned that the standard deviation is a measure of how predictable something is, how close do the individual data points come to the average. So the more dispersed your data is, the higher the standard deviation, right? Well, the same thing applies to stocks or to any investment. The more dispersed the outcomes, the more risky and the less predictable the asset. And we measure that by standard deviation. You've got ex post, which again looks back. If you were given the returns, if you had historical returns and you wanted to find what the standard deviation was. But you can also do it for the future. You can estimate what the standard deviation will be. Call that ex-ante. So you've got your formulas here. So we're going to use the same stock. And because we're looking at expected outcomes, we're going to use the ex-ante standard deviation. Because you have probabilities, basically, you're going to use ex-ante. So I'm going to paste the formula here. So we already know the expected return because we just calculated it. It was 32%. And you need that here. So I'll show you how to use this formula. So the standard deviation is the big square root. Remember your stats. Without the big square root, what you're finding is the variance. By putting the square root, you're finding the standard deviation. So it's the sum of the probabilities. So the first probability is 0.7 times the return, the corresponding returns, that would be 50%, minus the expected return of 0.32, and then you square it. You do that for all of your outcomes. Here we only have 2, so 0.3 times negative 10% minus 0.32 squared. That's it. So I get a standard deviation here for stock A of 0.27495, which if I convert to a percentage is 27.495%. Okay. Now, what if the returns had already happened, right? So now we'll look at ex post standard deviation. This is a traditional standard deviation, the same that you would have done in your stats class. The formula we're going to use is this one. It's kind of impossible to mix them up. So if you're wondering like, oh, how do I know which one to use? Well, in one of them you have probabilities and in the other one you do not. So it's kind of hard to mix them up. Now what you need first is you need the average. This is the average, very important. This is the arithmetic average, not the geometric. Very important. Don't use geometric here. You'll get the answer totally wrong. So we're going to start with that. So if I average them out, 25 plus 15 minus 20 plus 30 minus 15 divided by 5, the average return is 7. This is R bar. Now what you're going to do for each one is the return minus the average. So 25, that's the first return, minus 7. Squared, plus, and then you do each one. So the next one is 15. 15 minus 7 squared. Plus negative 20 minus 7 squared. Plus 30 minus 7 squared. Plus negative 15 minus 7 squared. All that over n minus 1, n being the total number of returns, your sample size basically. So in this case that's 5, so 5 minus 1. Big square root. So I get a standard deviation here of 23.08%. Because I left all my numbers in percentage form, my final answer came out as a percentage. If you had converted everything to decimals, your final answer would have come out in decimals. Works out to the same thing. Okay, so we've seen how to find the expected return of an individual asset in the past and in the future. We've seen how to find the standard deviation of an individual asset, which is how we measure risk or total risk in the past and looking ahead. Now we're going to focus on portfolios. So a portfolio is simply a collection of assets. So as soon as you buy more than one asset, well, you have a portfolio. Technically, even if you owned a single asset, that would be your portfolio. So the first thing to understand is that the total percentage of your portfolio that is made up of one asset is called the weight. Okay? And the weight of a portfolio is based on dollars. So if you had, for example, $10,000 in your portfolio and 6,000 of those dollars were invested in Apple, then we would say Apple makes up 60% of your portfolio. I know it seems obvious, but sometimes they'll try and confuse you and they'll give you shares. Say, oh, you have 10 shares of Apple and 14 shares of Amazon and 17 shares of Tesla. Completely irrelevant. I want to know the dollars. The total dollars make up the weight. So once you have the weights, then you're able to calculate things like the expected return of the portfolio or the standard deviation of the portfolio, which means the same thing, but now for your entire portfolio. The expected return of a portfolio is just a weighted average. Always just a weighted average of whatever you have within the portfolio. So this is that same case that we've been working on. Remember that the expected return for A was 32%. We found that earlier. For B, we gave it to you already. And now we're saying that we have $500 invested in A and $1,500 invested in B. So let's start by finding our weights. The weight of A is the total amount of money you have invested in A, in that case 500, divided by the total amount of money you have invested in both of them. So that would be 500 plus 1,500. In other words, you have 500 out of $2,000 invested in A, which is 25%. So the weight of A is 25%. For the weight of B, given that you only have two assets, you can just do 1 minus weight A. So if you have 25% of your money invested in A, it means you have 75% of your money invested in B. You can also do it the same way, where you take 1,500 divided by 2,000, you get the same answer. Now, if you wanted the expected return of the portfolio, we'll follow this formula. So the weight of A is 0.25. The return of A is 32%. The weight of B is 0.75. And the return of B is 13%. You're basically doing the weight, so weight A, times the expected return of A, plus the weight of B, times the expected return of B. And if you had a third asset, you do the same thing. The weight times the expected return. So I get an expected return of my portfolio of 0.1775, which is 17.75%. That is how much you're expecting to earn on any given year with this combination of stocks and these proportions. So that's pretty straightforward, I think. Nothing overly complex, nothing very technical. You have a formula, you use it. Now let's get into risk. Now, risk, when you start to combine assets, is a little bit more complicated. There's some more stats things you need to know. So let's start with covariance. You have two things here. You have the covariance and you have the correlation. You probably learned these in your stats class. We cover this in almost any stats class. Both the covariance and the correlation measure the same thing. Okay, they measure the direction of the relationship. So do the stocks move in the same direction? They go up together, down together, or do they move in opposite directions where if one goes up, the other goes down? The correlation takes it a step further, but we'll get to that. So the covariance, right? It measures the direction. A positive covariance indicates a positive relationship where they move in the same direction. A negative covariance indicates a negative relationship where they move in opposite directions. Now you want to be careful because you don't want to read any more into the covariance. The number of the covariance is not meaningful. It can't tell you whether the relationship is strong or not. You shouldn't interpret the number itself. Just look at the sign. We use the correlation for other things, when you want to actually know the strength of the relationship, but not the covariance. And the formula is here. You have two formulas, really depending on what you have to work with. If you have the correlation coefficient, this is the symbol for correlation, then it's great. It's super easy. You take the correlation coefficient, you multiply it by the individual standard deviation, so A and B, and that'll give you the covariance. That'll give you that relationship between A and B. If you have If you don't have the correlation, but you have that table that we've been working with all the different outcomes, then the formula is a little bit more complicated. It's not complicated, but it's longer, and it looks like this. Just FYI, these numbers here, these are the expected returns. Remember that expected return and average, they mean the same thing. So when you see a bar on top, it means average, it means expected return, it's the same. So I'm going to show you how to use the table. So I want to find the covariance between them. So I'll follow this formula. We'll see the other formula also just a little bit later, the one with the correlation. So we have the probability, which is 0.7, times the return. So that corresponding return for A is 50%, minus the expected return of A, which is 0.32. Now, instead of squaring it, which is what we did before when finding the standard deviation, you'll instead multiply it by the same thing for stock B. So the return is 10%, and the expected return is 13. And then you'll go down to the next row and do the same thing. 30% probability, negative 0.1 return minus the average. And then for B, 0.2 minus the average. Okay, let's punch that in. So you get a covariance. Another symbol for the covariance, if ever you come across it, looks like this. Sigma AB or SAB, something like that. But we'll just call it the covariance. And I got negative 0.0126. So again, the number itself doesn't tell me anything meaningful yet, but the sign, the fact that it's negative, tells me that A and B have an inverse relationship, where when one of them goes up, the other one tends to go down, and vice versa. And you can kind of see that in the table. During a high growth, stock A does very well and stock B makes 10%, okay. But then when you look at the recession, A goes down, but B goes up. A goes down to minus 10, but B goes up to 20. So there's that negative relationship between them. And we see that through the covariance. Now, why you need the covariance is because to find the standard deviation of the portfolio, it is not just a weighted average like it was for the return. Okay, it is in some cases, but those are exceptional cases. Normally, to find the standard deviation of a portfolio of two assets, you need to incorporate the covariance. And that's because, some theory here, when you invest in stocks that have a positive relationship or have a negative relationship, that actually affects the overall risk of your portfolio. What you want to know here is when stocks have a positive correlation or a positive covariance, when they have a positive relationship, it actually makes your portfolio more risky. So write that down. A positive relationship makes your portfolio more risky. And a negative relationship makes your portfolio less risky. Why? Well, negative relationships offset each other. And so if you're making money on one, you're losing money on the other. So your portfolio isn't really fluctuating. And that's what that's how we measure risk, the fluctuations. Whereas if they have a positive relationship, if one goes up, the other goes up. So you have a big swing up. And if it goes down, the other goes down, you have a big swing down. So that's why the relationships affect your total risk. The way we incorporate that into the formula is like this. This is the standard deviation for a two-asset portfolio. Now, we're not going to get into more than that in this class. In some other finance classes, you'll see 3, 4, 5 asset portfolios, but now we're only doing 2. So here we go. We have the weight, so we know that stock A makes up 25% of my portfolio and stock B makes up 75. We have the standard deviation right here for stock B, and the standard deviation for stock A, which we had calculated earlier, let me go get it, was 27.495. So we'll use that. Okay, so to find the standard deviation of the portfolio, I suggest you do it all in decimals. You could, there are ways to do it as percentages, but I suggest not. So the weight of A is 0.25, and you square that, right? So we're following this formula. The standard deviation of A is 0.27, I'll round that to 275, square. Then B. The weight of B is 0.75, so 0.75 squared. The standard deviation of B, 0.0576 squared, plus 2 times the weight of A times the weight of B times the covariance, so minus 0.0126. So you need the covariance to find the total risk of the portfolio. Okay, so let's punch this in. I get a total risk of 0.0432, which is 4.32%. And again, that risk is pretty low because the two have that negative relationship. If they had had a positive covariance, you'd see this risk would be much, much higher. So now that you understand the covariance, we can take it a step further and look at the correlation coefficient. So the correlation coefficient doesn't only tell us the direction the way the covariance does, but it also tells us strength. Because the correlation coefficient is bound by two extremes, -1 and +1. This means that the correlation coefficient can only take a value between -1 and +1, and therefore we're able to compare correlations to each other to know which one is stronger or which one is weaker. Now, a correlation of -1, right, far extreme to the left, -1, is a perfect negative correlation. I have a whole page on this. You don't really need to write this. And +1 is a perfect positive correlation. But the important thing here is that both extremes represent perfect correlations, meaning very, very strong correlations. And I have this written here. The closer you are to -1 or to +1, the stronger the relationship. The closer you are to 0, the weaker the relationship. A correlation of 0, in fact, is absolutely no relationship. Now, the correlation coefficient measures, like I said, direction and strength. But really, it looks at the tendency for two stocks to move together and how closely they move together. The formula is pretty straightforward. I mean, it's the covariance divided by the two standard deviations. Nothing crazy there. So let's solve this question. A portfolio consists of two securities, Nervy and Goofy. The expected return of Nervy is 12% with a standard deviation of 15. The expected return of Goofy is 9% with a standard deviation of 10. What is the portfolio standard deviation if 35% of the portfolio is invested in Nervy and the two securities have a correlation of 0.6? Now, in this question, you're not being asked to solve for the correlation coefficient. You rarely have to actually solve for the correlation coefficient, but you're given a correlation coefficient and you're asked to find the standard deviation. This is a very common question. So we learned just a minute ago that the formula for the for the standard deviation of a portfolio is this one. But what's important to remember is that in the formula you have the covariance, not the correlation coefficient. But earlier we spoke about the covariance and we talked about how there was a formula, which is the correlation multiplied by the two standard deviations. And this is the same formula as the one right above, just rearranged, right? If I take this and cross multiply, I end up with the other one. So we could basically rewrite this formula by getting rid of the covariance and replacing it with the correlation times the 2 standard deviations, and it would mean the same thing. But if you're dealing with correlation, this is the approach you want to take. So we know that the portfolio, 35% of the portfolio is invested in nervy. So I'm going to start my standard deviation of portfolio. So the first weight I have is 0.35 squared. And the standard deviation of nervy is 15. So 0.15 squared. Then the other weight would be 0.65. If 35% is invested in nervy, then the remaining 65% would have been invested in goofy. And the standard deviation of goofy is 10%. Plus 2 times weight A, weight B, correlation, so 0.6, times the 2 standard deviations, so 0.15 and 0.10. Okay, so let's punch this in. So I get a standard deviation of 0.1052, or about 10.52%. Now, the correlation coefficient has some important theory attached to it, and that's what I want to talk about next. The first one, and maybe the most important, is that when you invest in 2 stocks that have a perfect positive correlation, this means a correlation coefficient of +1. This provides absolutely no diversification. So what is diversification, right? I'm sure you've heard the word before, but it's basically when you take your money and you spread it around into different assets in order to limit your risk. If you put all your money in one asset, you have total risk of that asset. And if something, goes wrong with that stock, your portfolio is very exposed to it. But by spreading your money around, you're not super exposed to any one event. But if you pick 2 stocks that have a perfect positive correlation, what that means is if one of them goes up, the other one will go up by exactly the same amount. Meaning, if one goes up 1%, the other will go up 1%. They are perfect replicas of each other. So then there would be no diversification if you were to invest in those 2 stocks, because it'll be as if you put your money in one. So a perfect positive, now this doesn't apply for negative. In fact, a perfect negative correlation gives you the maximum diversification. The most diversification you can get is if you pick 2 stocks that are exactly opposites of each other. And that's what a perfect negative correlation is. But what I have highlighted in yellow, very important. Absolutely no diversification when you pick 2 stocks that have a perfect positive correlation. And then you've got these 2 shortcut formulas, which I think are useful. It's how you find the standard deviation of a portfolio, but in the extreme cases. So where you have a perfect positive correlation or you have a perfect negative correlation. For a perfect positive correlation, it's a weighted average. And this is the only time the portfolio standard deviation would be a weighted average of the standard deviations of the individual stocks. In any other case, it's not. But when they have a perfect positive correlation, it is. When it's a perfect negative, it's the same formula. You take the weight of A times the standard deviation of A, but you subtract it, so it's the difference. So I want to solve this exercise here, which is going to use this formula. Now, the purpose of this question isn't really to solve for the standard deviation, because again, not every question is going to be a cookie cutter, hey, here's a formula, plug in and find the answer. But you need the standard deviation to solve it. Let's see how. Security A has an expected return of 8% with a standard deviation of 6. That's a percentage. Security B has an expected return of 10 with a standard deviation of 9. The correlation between A and B is 1, so they're perfectly positively correlated. And so I know that the standard deviation of the portfolio can be found using this formula. If the standard deviation of the portfolio consisting of securities A and B is 7.6, so they've actually given you the portfolio standard deviation. What fraction of the total money has been invested in B? We're asking you for the weight of B. So this is a pretty common style of question where instead of giving you the weights and asking you to find the expected return of the portfolio or the standard deviation of the portfolio, we give you those things, or one of them at least, and ask you to work backwards to the weight. The key here is knowing which formula to use. Now, since they gave you the portfolio standard deviation, I'm going to use the formula for the portfolio standard deviation to answer the question. Had they given me the expected return of the portfolio, I would have used that formula. So I'm going to use this formula, again, for two reasons. One, I have the standard deviation of the portfolio, and because it's a perfect positive correlation, I know I can use this shortcut. The other thing, and this is probably the most important thing in this question, is when you're solving for weights, you always want to have one of them be a function of the other. So instead of weight A, I'm going to replace that with 1 minus weight B. And the logic there is that those two weights, whatever they may be, we don't know them, we know they add up to 1, no matter what. Weight A could be anything, and weight B will just be the complement of that needed to make the total 1. So if weight A is 20%, B is 80%. If weight A is 50%, B is 50%. So I don't know what they are, but I know that they are complements of each other in that sense. And so I could just move weight B over and say, well, weight A is 1 minus weight B. You do this so that when you get to the point of solving, you only have one variable. So look, I've got the standard deviation of the portfolio. Instead of weight A, I'm going to write 1 minus weight B. That'll be like my X. That's what I'm solving for. Standard deviation of A is 6. Weight B, standard deviation of B is 9. And now look, you have just one unknown, a little bit of algebra, and you get there. So let's solve this. So if I expand this, I get 0.06 minus 0.06 weight B plus 0.09 weight B equals 0.076. Bring this over. 0.016 equals 0.03 weight B, and then divide by 0.03. So the weight of B, the fraction of money you have invested in B, grab our calculators, is about 53%. I got 0.533. So about 53% of your money is invested in stock B. Okay, great. Now we don't have much left. The rest is pretty much theory. So we've been talking about risk a lot in this chapter, and I said earlier that when you're measuring risk, you measure it with the standard deviation, but that's if you're trying to measure total risk. But risk actually has two components. Total risk is the sum of systematic risk and unsystematic risk. So I need you guys to know what this means theoretically. And I'll use a stock as an example. When you buy a stock, there's two risks. There's the risk related to that stock or that company or that industry. We call that unsystematic risk, as many names. Asset-specific risk is one of them. Idiosyncratic risk is another one. They all mean the same thing. They are risks specific to an asset or to a company or to an industry. And then you have the risk associated to the market, like a recession, like changes in the interest rates, like wars, like pandemics. These are things that are not affecting one asset or another. They're affecting the entire market. And that's what we call systematic risk. Now, what are the things you want to know? Systematic risk is also called market risk, and it's unavoidable. You cannot eliminate market risk. You can trade it, so it's unavoidable. It can only be traded. Basically what that means is that, and we'll talk about this when we see CAPM a little bit more, but every stock, every asset has a certain amount of market risk. So if you don't like the amount of market risk you have, you can change where your money is invested into something else that has a different amount of market risk, but you cannot eliminate it. Whereas unsystematic risk is avoidable, because the more you diversify, the less you are exposed to any one stock or any one industry's specific risk. Try and imagine risk as a line where the y-axis is your risk and the x-axis is the number of stocks you have in your portfolio. You see, if you only have one stock, you're carrying a lot of risk. The more stocks you add, trying to make this curved, the more stocks you have, the less risk you have. But you can never get it to zero. You can never eliminate all risk. There's always going to be a certain amount of risk, and that's the market risk. That's the risk associated to the market. And you can have 100,000 stocks in your portfolio, which would be weird, but you can have 100,000. You can have all the stocks in the world in your portfolio. And if we go into a recession, your whole portfolio is coming down because all of those stocks would be affected by it. You're not eliminating it by diversifying. Whereas the unsystematic risk, the risk that is specific to any one of those, is virtually eliminated once you've diversified enough. If you only have 1% of your money in Tesla and Elon Musk says something on Twitter, even if Tesla were to crash, your portfolio would hardly move. You only have a tiny fraction of your money there. So that shows you that the more you've got your money spread into a bunch of different stocks, the less any one of those stocks can hurt your whole portfolio. Lastly, you've got something here called the efficient frontier. And this is kind of an old concept that is slowly being phased out, but it's still important for understanding kind of the basics. And it shows you the relationship between risk, return, and different portfolios. You've got return over here on the y-axis and risk on the x-axis. And the concept here is that there are certain portfolios that are better than others. Now that you've seen this chapter, you understand that with the same two stocks, you can make an infinite number of portfolios, right? You can have, for example, 100% of your money in stock A and 0% of your money in stock B. You can have the opposite. You can have 0% in stock A and 100% in stock B. And those two portfolios would be completely different. Or you can have any combination. You can have, I don't know, maybe this one here is 50-50. Okay, maybe this one right above it is 40-60. I'm obviously making these up. But the point I'm trying to make is you can sit there all day and make different combinations with stock A and B. But some are better than others. Why? Well, if you look at these two, they're made with the same two stocks. They have the same risk, but the one above it has a higher return. So for the same risk, you're getting a better return. So this portfolio, the one above, is dominating the one below it. This portfolio here represents the highest return you can earn for that particular amount of risk. And that's what every portfolio on this line represents. The maximum return you can earn for that given level of risk. And anything less than it is inefficient. So all of these portfolios, basically everything that is below the efficient frontier, we call these inefficient portfolios. And anything that is on the efficient frontier, and the efficient frontier really starts here at the minimum variance portfolio. So anything that's on that line from this kind of vertex all the way up, we call those the efficient portfolios. Those are the good portfolios. Anything above, those are unattainable. They are mathematically impossible. You would never be able to have this combination of risk and return with these two stocks. Okay? So nothing really else to this. Like I said, it's an old theory that is still lingering, but you should know it if you're learning this topic. So that brings to an end this chapter. If you have any questions whatsoever, please don't be shy, and I will see you next time.